Hi guys, this is Miss Hayes. It's Tuesday, March 31st. Hope you're having a good day. This is like my fourth time trying to make this video because I keep messing up, so hoping this one works. All right, so in Google Classroom, hopefully you found our assignment and our slides to get to this video. We have two things. We have our slides I'm gonna go over, and then we have the document. I made a copy for each of you. This is what you're handing in today, so no need to get into Amplify. So this is what our document looks like that we're going to answer, and then let's start with what we're going to do today. All right, so so hopefully you found the document. Get that open so that I can flip back and forth and show you. Review today's slides and video. I'm going to go through that with you today, and it will help you answer the questions that are on the document. All right. If there's anything I've taught you in the last 2 weeks of us being on Amplify and doing this remote learning, I need this to stick in your brain, okay? I still have some people that have not shown me that they understand this key concept, and I'm assuming it's the people that are also not watching the videos. But hopefully what we've learned by now is that when a material absorbs energy from light, the energy causes the material to change. So this is one of the things we saw in the sim last week, that when we put the genetic material, that's our DNA, right here, we shined the sunlight on it, we showed the energy, we can see that some energy is going through, right? But what causes that change, that damage here, is that we know that the material had to absorb the energy. And then I showed you a video last week from Vsauce that showed that when our cell's DNA gets damaged or altered, that's where cancer comes from. So what happens with skin cells is that they have this DNA here, right? And that's been damaged by absorbing too much sunlight. The kinetic energy also does increase, but that's not what's causing skin cancer. Skin cancer is going to be that damage to the DNA. Last week, we also put the light bulb on the DNA, the genetic material, and we realized that if I put the light bulb on, it increases the kinetic energy, but it doesn't damage the DNA. The only one that gets us that damage is the sunlight, which makes sense. Sunlight's a whole lot brighter, and there's more stuff going on with sunlight than a light bulb in your house. All right, so moving on to some new stuff. Remember, in Amplify, we have a mission every unit. So our mission in this unit is you are helping this Australian Health Alliance speak to the public. So now that you've had a chance to investigate the cause of skin cancer, the Australian Health Alliance would like you to write an explanation to share with the public. We have found that many people already know that light from the sun can cause skin cancer, but they don't understand how this works. Educating Australians about how skin cancer occurs is an important part of our campaign. So we need a scientific explanation that is easy to understand. So that is what you are writing today. And on our document, that is going to go in this box. So you're going to really make sure you take you're going to take your time. You're going to use complete sentences. You're going to write me a good answer here, and I'll explain a little bit later more. All right. So Australia's Health Alliance has given us 3 claims, okay? So claim 1, Australia gets a lot of sunlight. Claim 2, there is something different about the sunlight in Australia. Claim 3, more people in Australia have skin that is easily damaged by the light from the sun. And normally in Amplify, we've asked you like which claim is correct and all that. That's not what we're doing today. I don't know why. But instead, we're just going to focus on claim 1. That's what we've been learning about in chapter 1. So it says we're going to focus on claim 1 today. Think about what we've learned about light and the evidence we have that Australia gets a lot of light. There is a world map showing us the amount of sunlight, different areas of the globe. Then you're going to answer the questions. So we have this map here. We have 3 multiple choice, but you're not going to mark anything on these boxes. Instead, what I want you to do is just delete out the wrong options. So let's start by kind of going over reading this graph. So I'm going to do it this way. So I already read this to you. So you notice we have some different colors here. So we need to look at the key to understand what that means. So the total hours of bright sunlight per year on average. So this like ugly color right here, it's saying that it's under 500 hours of bright sunlight a year. So those are like in this region, I think that's those colors, but those lighter, weird, mustardy, yellowish colors, they're getting less light. As we start to get orangish, we're getting like medium amounts of light. And then if we get all the way to like some of these like really bright red spots, they're getting over 3,000 hours of light. So the big thing is the darker the red, the more sunlight hours, the lighter the yellow colors, the less hours of sunlight. Okay. So again, we are focusing on claim 1. So our claim 1, Australia gets lots of sunlight. Okay. So when I go to my document, then what we're going to do is we're going to compare some different parts of the world to Australia. So if claim 1 is accurate, would you expect Brazil's skin cancer rate to be higher, lower, or the same as Australia's skin cancer rate? So Australia, so if we can see, Australia is like this orangish color, right? Most of it is this like lighter orange color. Brazil is, in case we don't know, it's over here. So to me, those look about the same color. So would you expect, so claim 1's accurate that Australia gets lots of sunlight. Would you expect Brazil's skin cancer rate to be higher, lower, or the same? So if they look a similar color, right? What do you think? If claim 1 is accurate, would you expect Egypt's skin cancer rate to be higher, lower, or the same? And if we don't know, Egypt is up over here in this really darkish red color. So do you think Egypt skin cancer rate would be higher, lower, or the same as Australia based on the color here? And then the last one we're going to compare is Japan. And if you don't know where Japan is, it's over here. So it's this like yellowish color over here. Probably falls more into like this range. So do you think, would you expect Japan's skin color to be higher, lower, or the same? So we're just using this map to answer those 3 questions. Then for number 4, I want you to pick any comparison. The comparison between Brazil and Australia, Egypt and Australia, or Japan and Australia. And I want you to explain. And this is where you're doing a really good job writing me a really good explanation. Make sure you're using our vocabulary, absorb, energy, and light. Make sure you're kind of explaining this question, why is Australia's skin cancer rate so high? Make sure you might want to explain the claim, right? Claim 1. All of that is going into this answer in this box. Okay. So then next up, and I've shown you this before, we have, so this is the sunlight, the amount of sunlight. And now this one is showing us the actual skin cancer. And I want you to notice they don't match up. So again, Brazil, Egypt, Japan, Australia. Remember, the darker the color, the more skin cancer per 100,000 people. The lighter the color, the less skin cancer. So on our documents, what does the World Skin Cancer Map tell you about how skin cancer rates of Australia and Brazil are different? So what can you tell about Australia compared to Brazil on this map? And you might also want to bring back what we noticed here. So one thing we notice is Australia and Brazil are the same color up here on this map. So they're showing that they get the same amount of sunlight. Okay, so it's about 2,000 to 3,000 hours of bright sunlight a day. they're getting about the same. But Australia has way more skin cancer than Brazil. So that's what you need to explain in this box. And then this one, I don't expect correct answers yet. This is what we're going to lead into in chapter 2 and 3. But I want to know, do you have any ideas about how two places could have the same amount of sunlight, but different skin cancer rates? Can you think of any reason why that might happen? Okay, so again, I am grading this for correctness on 1 through 5. On number 6, I want to know your thoughts. All right, hope this was helpful. Miss you guys. And like always, contact me if you have any questions, concerns. I think I'm going to do a Zoom office hours at some point this week. So pay attention and talk to you guys later. Bye.